Hello and welcome to Remote University. We are all about learning videos. If you are here first time, please subscribe to our channel. If you are an existing subscriber, welcome back. Let's get into the video. In this video, we're going to talk about software testing in a software development lifecycle. What is software testing? Software testing is a process which is involved in the software development lifecycle. So if you are trying to develop an application in which after you complete writing the code and after you think it's ready, somebody needs to go and cross check whether it's meeting the actual intended requirements or not. So if you look at the definition of it, software testing is a process in a software development lifecycle to evaluate the functionality of the application in which it was developed to make sure it is meeting the specified requirements. So basically what we are doing here is, as part of the software testing, we are confirming the outcome of the product is meeting the specified requirements in the application development process. So what is software testing? It is confirming that product is meeting the requirements. Now that you know what is software testing, let's check when do we test in the software development lifecycle. If you look at the various phases of the software development lifecycle, what happens here is first the project or the application or the product will be planned. And after planning is completed, we start gathering the software requirements. So this is very important because this is what we are going to be used later in our testing. And after requirements are gathered, it will get into the design phase of the project. What we do here, we'll develop the UI, we will look at the framework, we will look at all the various other design aspects of the application or the project or the product. And then once the design is complete or in a final state, then the development will start. Based on the programming language that is being used in the development, the programmers will start writing the code. Either it can be Java, it can be C++, it can be C Sharp, depends on the product and technology that they opted, and then they will start writing the code. Once that development is done, then they will merge all the programs that they wrote and then put into a specific server where the testing part of the life cycle will start. So if you look at the overall life cycle, planning is first, then requirements are gathered, and then design is done, and then programmers will come and develop, and then the testing life cycle will start. So clear? So we are trying to understand the software development life cycle, and we are trying to see where and when the software testing is going to be started. Now that you know when do we test, let's see like how do we test. In a software development life cycle, after the development part is done by developers, the testing team will come into the picture. So they'll be asked to start validating the application. You can see people might be testing the application based on the type of the application. Whether it can be a mobile application, it can be a PC or a desktop based application, or it can be a tablet application where some product is developed for a store reps or like a marketing field or like a front help desk people you might be seeing nowadays in the hospitals, where they come to you with a nice iPad or some sort of tablet where the application is there, or it can be a specific application which is built just for a hardware. So irrespective of that, like the application needs to be tested. So how do we test? So there are various types of testing which involves in the software industry, but at the high level we categorize into two high level parts. One is manual, meaning the application that was developed can be tested manually. And second category is it can be tested through automation. So we'll discuss in the later slides like how the application test can be tested manually and how the application can be tested through automation. So the software testing again, the high level as we discussed in the previous slide is categorized into manual testing and testing using some automation. But within the manual testing or through the automation testing, there are various types of testing is there, which let's discuss. So if you look at the diagram here where we are trying to explain using the tree structure, whereas the software testing can be at the high level, static testing or dynamic testing. The static testing is nothing but if you have a screen or a web page where you might be glancing at the UI design or a prototype which was given to you and comparing with the outcome of the screen or the UI or the page or web page that was given to you after it was developed, where you are just comparing and saying it looks good from the color or font or like the various other UI elements. So this is nothing but static testing. So where you're not checking for any functionality, you're just looking at the UX part of the application. Whereas when it comes to dynamic testing, this is where you try to test the functionality of the application. So what is the functionality? So we talked about the requirements in the previous slide, where when a project is started after planning, they'll start defining the requirements and they'll start collecting the requirements, and then those would be used for developing the application by the programmers to meet the specific defined functionality. So that specific functionality is validated under the category of dynamic testing. So if you see here, again, the functional testing has categorized into two high-level categories. One is known as white box testing. Second one is known as white black box testing. So the black box testing is what the manual way of testing is used. So if you are a human and if you are going to the application and trying to, let's say, take the google.com as the example, where you go to google.com and type the google.com and go to search bar and say what is software testing, you will see the results. So assume like that was the development of the application that you are testing. As a human, as a person, you're going and typing something and verifying the results or outcome of that web page is something what you are looking for based on the requirements. So in this example, the human is performing the test without any specific tools or scripts. So that's why we call it as black box testing. So within the black box testing, there are various types of testing is included based on the state of the application. So for now, we can see the different types of black box testing which are performed in the application or a software development lifecycle. Some of them are listed here like integration testing, smoke or sanity testing, functionality testing, regression testing, system testing, user acceptance testing or UAT. So these are nothing but all are categorized under black box testing because a human or a person is executing or doing these type of testing. We will discuss in detail in the later slides of the or in a different video based on once we get to that advanced level of the testing activity. And coming back to the other type of the testing here, where the white box testing, or it is more known as the testing done using some sort of code or script. So this is mainly done by developers or the people who can code. So the reason that this type of testing exists is, so let's say the application that being developed is not only having a UI the human can go and test, but it also includes some APIs, application programming interface. So if there is any API or some sorts of microservices or any of the services are involved behind the UI, then a human cannot test all the functionality of that specific piece of code or API where it required another program to test the code which was previously written. So this is where the white box testing comes into picture. So within the white box testing, we have different categories underneath, like unit testing, or code, or statement, or path testing, and also branch coverage. So all these different types of testing is mainly meant for programmers or software development test engineers. So those are the two different roles which are being performed who has some sorts of programming skills. Whereas the black box testing is purely done by a person without any programming is included to test the functionality of the application that we are trying to test. Apart from functional, let's check the last category of the application testing. So we've seen the static testing, we've seen the functional testing and the dynamic testing, and the second type of testing under dynamic testing is called as non-functional testing. So when you go and look for a google.com, let's take the same example what we talked about a minute back, where you're trying to type something and look for the results. Sometimes you might be feeling that Google is too slow. It could be your internet connection, or it could be a state or a situation where millions of users might be using it, which is going to put some load on the servers, because when you so many users are going to hit at the same time, obviously it's going to be loaded. So all those checks has to be performed before we roll out to the actual users. So there are various types of such non-functional tests are there in the software industry, which are part of the testing types. Let's take what are those. So some of the non-functional testing areas are, as we discussed some time back, when users are trying to put the load by logging into the application at the same time, then we need to make sure like application still functions without any delay or response issues. So to in order to check that, we do load and stress testing. So this is one of the non-functional testing. And also compatibility testing. What is compatibility testing here? So let's say you are trying to use google.com on Chrome. You might be using other browsers like Firefox or Internet Explorer, or if you are on a Mac, you might be using Safari. But google.com should work on all these browsers. So this is nothing but compatibility testing. And if you are using a web application and accessing on a mobile, it should work just like iPhone. Same way it should also work on Android device. So this is nothing but compatibility testing. And other type of testing is security testing. So if you have a web application, like you might be hearing a website was hacked, or like it was stolen by some people, like by entering into their website, by recovering the admin credentials or something. So that sort of information should be prevented, where the application will go through some security testing to make sure there are no security issues with the application, which will result in some casualties after we release it to the public. Okay, so that is nothing but security testing. And then what is another area called recovery testing? In the software industry, like any application which is used by users will have user data within the application. Let's take an example of bank. You have an account there, and you might be depositing, withdrawing, or making payments, or transferring money. So you do all sorts of activities where the recovery of that user data is so critical for that specific application, where let's say if the server crash, still the data can be recovered. So it's similar. Think like you have a laptop where you're working on something, suddenly laptop power is gone, or like you ran out of battery, or it crashes and reboots on its own, but you still want your Windows Word document or Excel sheet, what you're working on, you want that to be recovered, right? Same way, the applications or products that we develop should have a way to recover the user data when any such activity like server crash, or like any certain sorts of issues happens in the application, which is nothing but recovery testing. So we will do a level of or a type of non-functional testing to make sure the application data can be retrieved or recovered when there is a crash. In the same way, there is one more type of testing is called usability testing. So if you are trying to access a, let's say, CNN.com. CNN.com, you might be reading the news, or you might be looking at the finance, or you might be looking at entertainment underneath, where the information presented to you, sometimes you might feel, if you're going to some website where there's so much on the page which is not so clear what you are looking for. That means it is not usable. The website is not so usable. But if you go to CNN or CNBC or any of these websites, you can see the information is so nicely arranged, because they do all that analysis, and it will go through usability testing to make sure it is good to use by the users. And the last non-functional testing requirement which we want to discuss is cookies. So these are nothing but software type of information which is stored within the browser. So when you go and type google.com, there is a bit of information which is stored within the browser within your laptop under the browser software folders. So what happens is, like if you go and browse something and come back and try to type that URL, you might be seeing the same being populated automatically. Or if you're trying to visit some other website, where if you are trying to Google for a new laptop, and if you are visiting CNN, after going to CNN, like you might be seeing the laptop ads there. So how the website of CNN knows that you're looking for a laptop? So this is nothing but cookies. Cookies will store your browser or history or activity that we are performing within the browser, which is being retrieved by the websites to find the information that you're looking for and then show the relevant ads. So that's one way of looking at how cookies are being used. Cookies are nothing but a piece of information stored within your laptop or a computer within the browser software. So to summarize, we talked about the types of software testing, which are basically like categorized into static and dynamic testing. And the most important part is dynamic because it's being the 90% of the testing, where we have functional and non-functional testing. And within the functional, we have discussed about white box testing, which is mainly done by programmers and testers, whereas the black box testing is done by a human or a person without any tools or without any scripts. And then non-functional requirements, which are nothing but where there is no functionality or outcome of the application is checked, but we are only looking at how the application behaves under some load, or if it is usable, or whether it's fully secured, or if it crashes, can it recover that data what the user was trying to enter. All sorts of testing is part of the non-functional testing. We looked at the various types of testing which are being performed in a software product. You might be thinking like, when do I do static reviews or static testing? When do I do dynamic? And within that, when do I do load testing? When do I do functional testing? So all sorts of questions you might be coming into uh, when it comes to software testing. So let's see the life cycle of the software testing. So similar to a software development life cycle where you looked at in the beginning what happens during the beginning of the project application development and what happens at the end. Same way, within that specific testing phase, we do have a software testing life cycle, which is being followed by any application that we develop which require a testing. So what happens in software testing lifecycle? So if you see here the two diagrams which we are trying to illustrate here, so same way like how a project is planned, what we do here is first we'll start with the analysis of the testing. So if you see during the software development life cycle, we gather the requirements. Same way here in the testing life cycle, we analyze the testing needs of the requirements. Based on the requirements, we'll see what types of testing is required here, what all needs to be tested, and what type of tools we need, what type of data we need. All sorts of analysis will be done here. Once we have the requirements and how to test and what to test, then what we do is we plan. We plan for the software testing. So during this planning, we will come up with a software test plan, and then we'll define overall the players in that, and then we'll see what type of test environment we need. We also think like what type of budget it will cost. All sorts of planning will happen in the test planning. So during this phase, you might be hearing, or if you already know the software life cycle, the person who is involved or a team who is involved in this testing life cycle will produce a deliverable called test plan. So we'll look at that in later videos in detail, what is a test plan. But just remember, like we will be creating an artifact called software test plan. And once the test planning is completed, we'll move on to software development test case designing. So we talked about the requirements here and we analyze them, And now we have requirements which are derived during the product or software development lifecycle. So those will be used to write test cases. So what is test case? The test case is nothing but for a specific requirement, what all the things that we need to verify against that requirement. So those will be defined within the test case. So we will again go in depth about test case designing and test case development in a separate videos. So just remember, like test case is nothing but a step or a function that we try to validate, which is being defined against the requirements. So then once we have test cases in place, then what we should do, we will be setting up the environment. So we talked about in the test planning, like what type of environments that we will be needing to do this testing. So once we have the test in environment is available for us, that needs to be set up to begin the testing once the application code is available. And once that environment is set up and running, we'll wait for the developer to give us the code or deploy the application there. And once the application is handed over to the testing team, then we'll start executing the test cases what we developed here to start evaluating the software that was given to us. Again, this was done within the environment where we are trying to test. And after executing those test cases in this environment against the requirements, then we'll produce the outcome of the test results, and then the test life cycle is going to be ending there. So during this phase, when you're executing, you might be coming across some defects which will be logged and given to developers for fixing them. And once they are fixed, we'll retest, and then that life cycle will be completed. So same thing will be compared against the software development life cycle here. So if you look at here, how the analysis of the software, design, implementation, and testing, deployment, and then maintenance is involved in the software development lifecycle. Same way, software testing lifecycle also involved analysis, planning, development of test cases, and then set up the test environment, and then start executing those test cases, and then submit the report whether those test cases are passed or failed based on the outcome. Now that we've seen what is a software testing lifecycle, let's check what is going to be the outcome of the lifecycle, where I mentioned in the previous slide, during the software planning, software testing planning, we will deliver a artifact called test plan. So we want to look at in detail what are the various artifacts or outcomes of the various phases of the software testing lifecycle, which is going within the software development lifecycle. So as we talked about software development lifecycle, what happens first? After project is being planned, we'll gather the requirements. During this phase, while the project or application or product requirements are being gathered, the testing team will parallelly work on acceptance testing plan. So this is very important, because any application that we work on, when we want to test, we want to make sure the application is meeting the requirements and we're going to be accepting the outcome of the development product. So that's why we define there's a activity called acceptance test plan. Okay, and then after the requirements are gathered, the application is being defined in order to make sure that design requirements are being discussed. Like for example, what type of program or technology or frameworks needs to be used, that is being defined within the software application, and then they'll get into the design. At the same time, what happens to testing team? Testing team is working parallelly to make sure we define the system test planning, because when you're using a Java program to develop the application, if that Java program is being embedded or integrated with the existing ecosystem of the company, how that is going to be performing to to meet the outcome of the application requirements. So we define our system test plan to ensure our application is tested in the overall system of the company. So the artifact here is system test plan, and the type of testing that we perform is called as system testing. And then in the project development lifecycle, the next phase is high level design. So when we are doing any application development, it is very important that the technology team or development team defines how the application is being designed from UI aspect and from technology aspect, and then what are the different reusable services and all that is defined and discussed, and then they'll finalize during the high level design phase. During this phase, they might be designing to have the application functioning within the existing system. So let's say a application has two different modules, and we are trying to develop both. That means those two modules should work together, and also they should work when we are integrating with the existing system. So during this phase, the testing team is parallelly working on making sure the integration of the applications are properly working. So we need to define our integration test plan. The type of testing what we do is known as integration testing. And then what happens after high level design is done from the development team, they will move into low level design or detailed design phase. During this phase, the type of test plan is known as unit test plan. This is mainly done by the developers who are writing the code. So they will have the low level design and they'll define the unit test plan, how the application code needs to be tested, and then they'll perform the unit testing. So if you look at here, the next activity is nothing but coding of the application. So basically what we looked at here is a V model diagram, which is one of the models that software development lifecycle has to illustrate what happens during the software development lifecycle with comparison to software testing lifecycle. So the two life cycles are parallelly compared and discussed on the various artifacts being produced at each phase of the development life cycle. So along with the software testing outcome, once the test cases are designed and we looked at in the life cycle, the test cases are designed and then they're executed. And then you might be wondering what happens after that. As I mentioned, the report will be delivered to the team saying out of this many test cases that we executed, some of them are passed, some of them might be failing, where I mentioned those test cases which are failed, might be reported. How do we report? So there are various ways for this outcome to be reported. So nowadays, most of the teams are using some sorts of software testing tools, and the one which we are looking at right now in the presentation is known as TestRail. So this is one of the commonly used application tool which is used for test case designing and test case execution. So where you can define all the test cases that you are trying to design, and once the code is available to the testers, they'll start executing them and then mark them as passed or failed. And if you are not having any defects, then everything will look good and everything will be green and a person will be passed it. But if there are some issues, then you mark them as failed and then you file some defects. But sometimes what happens is like after we complete the testing, like sometimes we might need to retest some of the scenarios based on the defects, because after a defect is being filed for a failed scenario, developer is fixing that and touching the code. So we might want to retest some of the scenarios to ensure like they're still working after the fix is being given to us. So that's why you see the various states: failed, retest, blocked, passed. So blocked means like when there's a test case which we want to execute, and that test case cannot be executed because of some reason where you don't have the test data, or the developer is yet to deliver that component or piece of code which will enable that feature to test. So until you get that, or until you receive that data or piece of code, you mark the test case as blocked in your report. Clear? So basically, the test summary is produced through some sort of tool by executing the test cases which are being designed in a life cycle. So it can be a simple email report, it can be a tool report where you can just take the screenshot and then attach it to your email, or it can be an online link which can be shared with the team to look at the current state of the application testing. You've seen in the previous slide, we talked about the outcome of the testing, where we are saying some of the test cases are passed, some are failed, some are retest mode, some we are calling it as blocked. So what happens when we say test case is failed? That means our test case is failed because it is not meeting the actual functionality which is being observed in the application that we are trying to test against a requirement. So during that, what we should do as a tester or a test resource, we need to communicate that to the developer, saying this is what our observation is, where the specific requirement is not being functioning as we wanted, or it might be functioning but we are seeing some observations, or we might be totally not seeing that specific requirement being coded. It's again like developers are humans, they might be forgetting, or they might be forgetting to merge the code what they wrote when they gave the application to a tester or testing team. So how do we communicate to the developer on what we are observing? So in the software development lifecycle, when we start testing, the defects what we find, or we also call them as bugs, what we find or what we observe needs to be reported to developers through some form. With the latest trend, there are so many tools being available which are being used by the companies or the organizations across the world. It can be a simple email to development, which is not recommended because it's not something we can track once we send. Or The most commonly used is use a tool based on your organization's adoption. And the most commonly used defect tracking or bug tracking tools are listed here. The one which I used in most of the career are Zira and Bugzilla. These are the most famous ones within the industry, and rest are like again depends on the nature of the team and the type of the company that you're working in. But Jira and Bugzilla are the most commonly used, apart from some other the industry adopted tools. But I listed here to just to give you some names. What are the different defect tracking tools currently in use in the industry? So if you are looking for a definition of what is the defect or a bug, so the defect is a so in a software product represents the inability or inefficiency of the software to meet the specific requirements and criteria, and subsequently prevents the software application to perform the expected and desired functionality. So basically, the defect is something which is preventing the application to perform what we wanted it to be performed. Now that we looked at the software testing life cycle, and then how do we write the test case, how do we execute them, and how do we report the defects, the next step is in a life cycle we need to start sending the test summary report. For any application that you're testing, as I said, like you need to communicate to the team or developer or the stakeholder saying, so this is what we did, these many test cases are executed, these many are pass fail. All that needs to be sent in a summary that can be shared via tool, or it can be a report that you send email, or it can be a online dashboard. So there are various ways how you can summarize your testing and then send it to the stakeholders at the end of the day or at the end of the project. Depends on the cadence that your team or company is expected to deliver. So in a nutshell, like after you complete or during the testing, uh, we need to send a test summary report. So this is a document or a report which consists of summary of testing activities and results. It also consists the evaluation corresponding test items against exist criteria. So this is another way of looking at, like, once you complete the testing, if you want to exit the testing phase and go to the next phase, which is deployment, what is looked at is what are being performed during the testing, and what is the outcome of the testing. And sometimes, like if you still have like some minor glitches, the companies are okay to proceed and deploy into production and then continue fixing those. So all that information is being reviewed and communicated in a format called test summary report. Thanks for watching. Please support our channel by liking or commenting or subscribing to our channel if you are new and coming to our channel first time. Thank you. Thanks again for watching.